everyone, I'm Krupa, student teacher of Bombay Teachers Training College, Kollam. So today I'm here to show you all some experiments of some simple topics of science such as surface tension, air pressure and friction. So to begin with, I'll just demonstrate an experiment showing the surface tension phenomenon. So for this experiment we need a glass of milk, some soap water, some food color, yellow I've taken and green, and a earbud. So I'm pouring the milk into the plate. So let's basically first understand what is surface tension. Surface tension is a property of the surface of the liquid, which resists the external pressure on the surface of that liquid. Have you ever noticed why water droplets are spherical in nature? It's because of surface tension. It is because the water molecules stick to each other and they exert a pressure on the surface of the liquid. So we'll now start with the experiment. So I'm taking a food color. So I'm putting it into the milk. I'm taking another. So now we'll dip this earbud in the soap water and see what happens here. So as you've all seen, that there is a rainbow-like formation in the milk. So now this is because the soap water is reacting with the milk and the fat of the milk. So because of which the milk particles, they tend to move out of the way, and they tend to and the surface tension is broken here of the surface of milk. So so you all have understood what is surface tension and how it works. Stop. So now I'm going to tell you about the air pressure. To understand this concept, I'm taking a bottle, an empty bottle, and I'm trying to crush it. Okay, so I'm trying to crush it. So it's not happening. It's requiring a lot of effort. So why is this so? So now I'll remove the cap and see if what is happening. So I'll remove the cap and I'll try to crush it. So this is happening easily. Why? So there is pressure. Now we have heard that air is everywhere, everywhere, inside out, everywhere. So now when I'm closing this bottle with the cap, air is exerting a pressure to the sides of the bottle. So that's the reason it is not getting crushed easily. Okay, so this term, scientists have termed it as air pressure, the pressure of the air. So now I'll demonstrate another experiment, this thing to make it more clear. So I'm trying to put this paper ball in this plastic bottle. So you all might assume it to be an easy task, but this will not happen. Okay, so I'm doing this. So you all can see that the paper ball is going, but it is again coming out. So why is this happening? So it is nothing but Bernoulli's principle. The faster the air, slower is the pressure. Okay, so I'm trying to make this paper ball go inside of it, but it is not going because the size of the bottle is large and the pressure, so the speed is slow and the pressure is more here. So that's why it is not going. So for to make you understand little more nicely, I'll take a glass of water and I'll put it in a plastic bottle. So I've taken a tray. Okay, so I have made holes to this bottle. I've made 2 holes. So I'm trying to so the water is not coming here out of the holes. Even if there is a hole inside the water is not coming. Why is this so? It's because air pressure inside the bottle. Because of the pressure, it is not allowing the water to come out of the hole, because there is pressure inside the bottle. Okay, so now I'm just opening the lid, and now you all can see that the water is coming out easily. Now I'll try to just crush the bottle, so you all can see that the water is moving out quite easily. So why is this happening? This is because I'm releasing the pressure inside the bottle, which is there inside the bottle, and then the water is coming easily. Okay, so this is air pressure. Thank you. So now we'll learn the third concept, that is friction concept. So what is friction? Friction is the force between the two substances, which due to which the substances bind to each other, and they tend to stick to each other. Okay, so I'll elaborate the friction topic in a video that I'll be showing you all. But let's just figure out what is friction and how it works. So I've taken a bottle with rice in it. So I'll just try to lift the pen which is inside the rice. Okay, so I'm trying to do that. So when I'm trying to lift the pen, the bottle is also coming along with it. So this is why is this happening? It is because the friction, the rice grains have stuck to each other firmly, so it is not allowing the pen only to come outside. The whole bottle, it is coming outside. The whole bottle is getting lifted up. So this is friction. Now I am showing you all a video in which I'll explain it more clearly.
In this video, in this experiment, we'll learn about friction. How do things move? Say a ball is moving on a flat ground and there is no external force acting on it. Will the ball eventually come to a halt? Yes, it will. Have you ever wondered why? Say you're skating on an ice ring and your friend is skating on the road. Whose movement do you think will be smoother? Definitely yours. When you hold the bottle in your hand, why doesn't it just slip through and fall? Sometimes when you're walking, there's a caution board about and it warns you about the floor being wet. What explains all this? The answer is friction. The reason why the ball eventually comes to a halt is because of the force of friction. The reason why skating on an ice ring is easier is because the force of friction is lesser there. The bottle doesn't slip through your hand because the force of friction between your hand and the bottle doesn't allow it to do so. If the floor is wet, the friction offered by it reduces and there are chances that you might slip and fall. So what is this friction we are talking about? It's quite easy to understand this concept. Friction is nothing but a force. It is the force exerted by a surface for an object when it moves across. In the first case, when the ball is moving in this direction, the force is acted in opposite direction. The force of friction offered by the ice is lesser than the force of friction offered by the road. Hence, skating on ice ring is easier and seems effortless. The bottle doesn't slip down because the surface of your hand offers a friction in the opposite direction. And in case of the floor, the soapy water reduces the force of friction offered by the floor. About